Hello friends, a very warm welcome to another session pertaining to CSAT examination, and today's topic is mensuration. There are two parts in the topic mensuration. The first part will be dealt with in this session, and it is 2D or two-dimensional figures. In another session, we will discuss 3D or three-dimensional figures. Now, essentially, at least one question has appeared in CSAT examinations, which means that you are assured of earning 2.5 marks. So let us know these figures, various formulas and concepts related to them, and then let us find out a way of solving these questions by using the shortest possible and the most accurate method. So talking about two-dimensional figures, let us list them out here. The first one is triangle, and you know that there are various types of triangles. We have equilateral triangle, then we have an isosceles triangle, we have a scalene triangle. Now these are three types of triangles based on the size of the sides. Now in equilateral triangle, all three sides are equal, which also means that all the three angles are equal, 60 degrees each. In an isosceles triangle, two sides are equal, which also means that two angles will be equal. And in a scalene triangle, all three sides are unequal. The three sides will have different dimensions. So we know that an equilateral triangle will have all the three sides equal, and which means all the three angles will also be equal. An isosceles triangle will have two sides equal, third side unequal. These two angles will be equal, third angle will be different. And a scalene triangle could be a triangle wherein all the three sides are different, their measures are unequal. Apart from that, we have another type of triangle, and that is called right-angled triangle, in which one angle is of 90 degrees. This is how it will look like. This is a right-angled triangle. Square, it's a parallelogram, or you can say it's a quadrilateral. Obviously, we are talking about a four-sided closed figure in which all the four sides are equal. Each of them, let us say, measures A units. Also, all the four angles are equal, each angle being 90 degrees. Now also, please notice that a square is a parallelogram. Rectangle, another quadrilateral, which is a four-sided closed figure. Opposite sides are equal and parallel, but there are two pairs of equal measures of sides. But there are two pairs of sides which have equal measures, and these two sides in a pair will also be parallel to each other. Needless to say, all the four angles are at 90 degrees. So we talk about a parallelogram. A parallelogram is any four-sided closed figure or a quadrilateral in which opposite sides are parallel and equal. So rectangle is also a parallelogram, and usually the kind of diagram which is used to represent a parallelogram has a slant here, as you can see. So these two sides are opposite and equal and parallel to each other. These two sides are also opposite, equal and parallel. Trapezium. A trapezium is again a quadrilateral which has got four sides. So it is, let us say, a four-sided closed figure. This is a regular trapezium in which one pair of opposite sides will be parallel but unequal. The other two sides will have different lengths. And then there is something called a right-angled trapezium, in which one of the angles formed is 90 degrees. And as you can see, these two sides are parallel to each other, but they are not equal. The other two sides are neither parallel nor equal. Rhombus. A rhombus at times is mistaken with an inclined square, a square which has been pushed or rotated, let us say, by 90 degrees. In a rhombus, the opposite sides are equal and parallel, and also all the four sides are of equal measure. But the two diagonals which are there are of unequal lengths. This is diagonal 1 and diagonal 2, and the two diagonals intersect, or let us say bisect each other at 90 degrees. Let's talk in detail about triangles. Some of the features, the sum of the three angles is always 180 degrees. So if at all, let us say this is a triangle, this is angle X, this is angle Y, this is angle Z, then x plus y plus z, the sum of the three angles, shall always be equal to 180 degrees. The sum of the lengths of two sides is always greater than the length of the third side. So what I mean to say here is that let us say that if we have this triangle, this is 3 centimeter, this is 4 centimeter, this is 5 centimeter, then we know that 3 plus 5 is 8 and 8 is greater than 4. The sum of the two sides is always greater than the fourth side. 4 plus 5 is the sum of two sides, that is 8, greater than the third side, which is 4 units. 5 plus 4 is 9, which is greater than the third side, that is 3. Now similarly, 3 plus 4 is 7, which is greater than the third side, 5. So if you come across a triangle which has three sides, such that one side measures 3 centimeters, another side measures 6 centimeters, and the third side measures 2 centimeters. Now this triangle cannot be formed. This is not a triangle. Reason? 3 plus 2 is not greater than the measure of the third side, which is of 6 centimeters. 5 is not greater than 6. Now for that matter, instead of 2, even if this would have been 3, still 3 plus 3 is not greater than 6. It is equal to 6. So essentially, mandatorily, compulsorily, the sum of the measures of two sides of a triangle must be greater than the measure of the third side. So that is an important rule. We just talked about the types: equilateral triangle, isosceles, and scalene, and the right angle triangle. In general, the area of a triangle can be defined as half into base into height. So if it is a right angle triangle, let us say this is called the perpendicular, or let us say the height. This is base, and this shall be termed as hypotenuse. Now this happens to be a right angle triangle, and if perpendicular is represented by P, hypotenuse is represented by H, and base is represented by B, in that case kindly know that P square plus B square equals H square, or let us say H equals square root of P square plus B square. Now this is through a theorem which is called Pythagoras theorem, which is used only for right angled triangles. In other triangles also, let us say if we know the height, which will be 90 degrees to the base, then we can employ this formula to find out the area of that triangle. Now area is the total space which is encompassed in these three lines which form the closed figure called triangle. So in a triangle, this particular space is called the area. Now perimeter, what is perimeter? Perimeter is sum of measures of all the sides of a figure. We are talking about a triangle. A triangle has three sides. So let us say the three sides measure A, B and C. So the perimeter would become A plus B plus C. Now there is another concept which is used in a formula, and that is semi-perimeter. Now semi-perimeter is denoted by S, which is used in the formula for finding out the area of a scalene triangle. So as the word semi means, so half of perimeter. So this we know is perimeter, A plus B plus C divided by 2, and that is represented by the letter S. Now let's have a look at the table here. In this table, you're given all the four triangles. Their areas are specified. Kindly know this, that area for an equilateral triangle is denoted by root 3 by 4 into A square. The perimeter anyhow is 3A because an equilateral triangle will have three sides measuring the same, that is A. So A plus A plus A, it will become 3A. So simply perimeter is the sum of all the sides. Isosceles triangle, the area will be found out by using the formula B by 4 into square root of 4A square minus B square. The perimeter shall be 2A plus B because in an isosceles triangle, as we know, two sides measure the same. So let us say these are the two sides measuring A units, and adding the third side, that is B, will give us 2A plus B. Scalene triangle, as discussed, the perimeter would be sum of all the three sides, which will be unequal. So A plus B plus C. Now, we know that we can find out the semi-perimeter by taking the half of the perimeter, that is a plus b plus c divided by 2. Now while finding out the area, kindly know that the area of a scalene triangle is given by under root of s into s minus a into s minus b into s minus c whole under root. Right angle triangle or any triangle, the area can be found out by using the formula half into base into height as we had discussed, and obviously the perimeter remains the same, a plus b plus c. Quadrilaterals, what are quadrilaterals? These are four-sided closed figures. Now some rules: the sum of four angles of a quadrilateral is always 360 degrees. Now in the case of a triangle, the sum of three angles was always 180 degrees, whereas in a quadrilateral, the sum of the four angles, let us say A, B, C and D, shall always be equal to 360 degrees. Now in a parallelogram, the opposite sides are always parallel and equal. Now parallelogram is a type of quadrilateral as we had discussed earlier. Types of parallelograms that we have already discussed is a square, a rectangle, a rhombus. Other quadrilaterals, we have trapezium, and irregular quadrilaterals like a figure which is neither a square nor a rectangle nor a rhombus nor a trapezium. It's an irregular quadrilateral. Now for finding out the areas and the other details, now here we have a table which depicts or shows the area, perimeter and diagonal for various quadrilaterals. For a square, the area is a square. Now kindly know that each square is a rectangle, or every square is a rectangle, but not the vice versa. All rectangles are not square. But yes, all squares are rectangles, but not vice versa. That is, all rectangles are not square. Now first let us discuss about the area of a rectangle. Now this is how a rectangle looks like. This is length and this is breadth. Usually length is the longer side. Now these two sides measure the same. These breadth, they may measure the same there because the opposite sides are equal and parallel. The area is always given by length into breadth. Now because a square also happens to be a rectangle, and we know that each and every side of a square measures the same. That is, let us say a units. So in that case, the area of a square will be length into breadth. Now length here is a, breadth also is a. So a into a will give us an a square. So area of a square is a square. Perimeter is sum of all the four sides. Each side is a units. So the sum of four sides will become 4a units. Diagonal of a square is measured as a root 2. Now why is it so? If this is a square, this is a diagonal. Now diagonal is basically a line which joins these two opposite vertices. It's a slant. This is a, and we know that each angle in a square measures 90 degrees. We can apply Pythagoras theorem. So d here shall be equal to square root of a square plus a square, which is nothing but square root of 2a square. For a square, we can take an a out, so it shall become a, and remainder is 2. So a root 2 is a measure of the diagonal of a square. Rectangle, as we just talked about that, for the rectangle we have already discussed that the area is length into breadth. Perimeter shall be the sum of all the four sides here. So 2l plus 2b, 2 taken as common, so it shall become 2 into l plus b in brackets. Now when we talk about the diagonal here, this is how it looks in a rectangle, and the measure of that again, because in a rectangle all the four angles are equal, 90 degrees. Hence here we get a right angle triangle. We can always apply Pythagoras theorem. So this is L, this is B. So square root of L square plus B square shall be the measure of the diagonal of a rectangle. Parallelogram. Simply, this, let us say, is the height. This is the measure of the base. So the area for a parallelogram can easily be found out by using the formula base into height. Now let us say that these two sides are parallel and equal and they measure L1 units each. These two sides are parallel and equal, they measure L2 units each. So when you find out the Perimeter, it shall be L1 plus L2 plus L1 plus L2, that is 2 times L1 plus L2. This shall be the perimeter. For a rhombus, we know that all the 4 sides are equal. And one more thing, every square is a rhombus, but every rhombus is not a square. Because of the basic property of a rhombus that all 4 sides are equal. Now these are diagonals. This shall be diagonal D1, this shall be diagonal D2, the horizontal one. So area is easily found out by multiplying these 2 diagonals and taking half of their measures. That is half into D1 into D2. Once again, the perimeter is 4A, that is adding up all the 4 sides. Trapezium, well, this is a trapezium that we have. These 2 sides are opposite and parallel, but they are not equal. So here, let us say if we know the height h, which is at right angles here on the base, and let us take the measures of these 4 sides as A, B, C and D. In such a case, the area of a trapezium can be found out using the formula here, that is half into height, this is the height, into sum of the parallel sides. Now these 2 sides are parallel and their measures are A plus C in this case. So this is how we will find out the area of a trapezium. Perimeter anyhow is nothing, but it is a sum of all the 4 sides. That is A plus B plus C plus D in this case. Circle, a very, very important figure. And we know this is how a circle looks like. Now please note that diameter is the longest chord. What is a chord? Chord is a line which joins any 2 points on the periphery of a circle. See, a circle is made of, let us say, infinite points. Any 2 points, if you join with each other, the line so formed will be called a chord. Now this is also a chord. All these are chords. But the longest chord will be called the diameter, which runs or goes or passes right through the center of the circle. Now radius of a circle is half the measure of the diameter. You can say 2r or twice the radius is diameter, or we can say d by 2, diameter is half is radius. So this much is a radius. This again, as you can see here, is a radius. Now circumference of a circle is the measure of its boundary. Or so as to say, this complete figure here, which has been drawn through this marker everywhere here, this is circumference. Or let us say the fence, the boundary of the circle. So this complete ring, so this boundary of this ring or this circle is called its circumference. Now semicircle is half of a circle. Well, and this is how it looks like. Let us say if this is a full circle, this being its diameter, I take this out. This is the half of a circle, which is called a semicircle. Semi anyhow means half. An arc is a curve on a circle. So let us say if this is a circle here, this would be an arc on the circle. Or let us say an arc is a partial curve on the boundary or circumference of the circle. The arc with the greatest length is called the major arc. Now let us say this is a circle and this is a chord. The measure of the chord, let us say, is PQ, joins these 2 points on the circle. Now this chord divides the circle into 2 parts. Now this curve is larger than the other, so this shall be termed as major arc, whereas the arc with the lesser length is called the minor arc. Well, as you can see, the smaller of the 2 arcs is this. This is a smaller arc, a smaller curve as compared to the yellow curve. So hence this shall be termed as minor arc. Major, large. Minor, small. A sector is formed by joining the 2 ends of an arc with the center of the circle. Let us say here this is an arc here. If we join this arc with the center, this part here becomes the sector of the circle. Well, a very easy way to understand this would be that when you observe a pizza, it is divided into various sectors. This is how a pizza looks like, isn't it so? And we are always trying to measure with our eyes which is the largest piece. And we try to catch hold of it as fast as we can before anybody else does. So each of these pieces in a pizza shall be termed as a sector. So in the curved figures, we have circle to find out its area. Kindly remember, it is pi r square. And if we are given diameter, then it is pi d square by 4. And why is it so? Well, pi r square, we know that r is equal to d by 2. So let us substitute it here. We shall get d by 2 whole square, which becomes pi d square by 4. Circumference is 2 pi r, or let us say pi d, because d here equals 2r. Diameter is twice of radius. Now that's what we are talking about here. Now an arc, because arc is only a curve, so a curve is a line which is bent, so it doesn't have an area. But yes, it would definitely have a length. So 2 pi r theta by 60, or let us say 2r can be written as d, so pi d theta by 360 degrees. Let us say you have to find out the length of this arc between these 2 points. We shall join this with the center, and there would be an angle between these 2 points. Let us say P and Q. Now this angle is represented by theta. So these are the 2 points P and Q. This is the angle, that is theta. So the length of this arc is found by multiplying the circumference with theta by 360 degrees. Now similarly for a sector, the area shall be written as pi r square theta by 360 degrees. Now let us say that this is a circle. This is the center of the circle. We have to find out the area for this sector. This is P and Q. This is, let us say, center O. Once again, this would be the angle theta, which is formed between the points P and Q with the center O. So when we want the area of the complete circle is pi r square, and you want the area of a sector, it is theta by 360 degrees. Now let us solve some questions to register these concepts in our mind. The perimeters of 2 squares are 48 centimeter and 64 centimeter. What will be the perimeter of a third square whose area is equal to the difference between the areas of the 2 squares? Let's go slow. Now first of all, there is a square whose perimeter is 48 centimeters. There is another square whose perimeter is 64 centimeter. Now what is the perimeter of a square? Perimeter of a square is 4a. So that means that each side of the small square shall be equal to 48 by 4, that is 12 centimeters. And in this case, each side of the square shall be equal to 64 by 4, that is 16 centimeters. Now the area of the third square is equal to the difference between the areas of the 2 squares. So area of this square shall be 16 square. Area of this square shall be 12 square. So the difference between the two has to be positive, because area is always positive. It cannot be negative. Have you heard of minus 10 centimeter square kind of an area? Obviously not. So area here becomes 256 minus 144. That equals 112 centimeter square. And we also know that this is a third square. Its area here has to be the square of both its sides. Let's say that this is a third square and each side is of x centimeters. So x square equals 112 centimeters square. So x here would be equal to square root of 112. Now this can also be written as 16 into 7. 16 into 7 is 112. Now we know that 16 is nothing but it is 4 square, or let us say 4 into 4. So 4 for this will come out, and what will remain inside is root 7. So 4 root 7 centimeter is the side of the larger square. Now the question here is perimeter of the third square. So perimeter is to be used here as 4x, yx, x, the value of x here is 4 root 7. So it shall be 4 into 4 root 7, which shall become 16 root 7 centimeter. Now that should be the correct answer here. Now if the length of a rectangle is increased by 20% and the breadth is increased by 30%, then by how much percent will the area of the rectangle increase? Now initially, let us say area of the rectangle, let it be length into breadth. Now the new area shall become, now there is an increase of 20% in the length, so length becomes 1.2 times itself, and breadth is increased by 30%, so the breadth becomes 1.3 times itself. So it is 1.2 into 1.3 into L into B. Now what is this L into B? It is the area, the original area. And what is 1.2 into 1.3? Well, 12 square is 144 plus another 12 will give us 156, which is nothing but 12 into 13. So 1.2 into 1.3 should give us 1.56 times the original area. Now L into B is area, the original area. So the increase is any figure which comes after the decimal. So this means that the area increases by 56%. Now that is one way. Now if you recall the concepts which were taught to you in percentages, for such kind of increases we always use the formula x plus y plus xy by 100. So there is an increase of 20%, there is an increase of 30%, plus 20 into 30 by 100. This shall be 50, plus 2 into 3 is 6, so hence directly 56% increase. Now the length of a rectangle is decreased by 10% and the width is increased by 20%. Then what will be the effect on its area? Now let us not call it a question which is based on mensuration. This is more of a question which is now based on percentages. So once again employing the formula x plus y plus xy by 100 decreased by 10%, so minus 10. Width is increased by 20%, so plus 20, minus 10 into 20 by 100, zeros cancel here. So minus 10 plus 20 is plus 10, and this is minus, only 2 remains here, right? So minus 2. So there is going to be an 8% increase in the area. That will be the effect. Now the ratio between the length and breadth of a rectangular plot is 5:4, and its area is 1280 square meters. Now what is a perimeter of the plot? So this, let us say, is a rectangle. The length, let us say, is 5x, and the breadth in that case shall become 4x, because the ratio between the length and breadth is already specified as 5:4. So let us take the actual values as 5x and 4x, x being the common multiplier. Area of a rectangle we know is length into its breadth, that is 5x into 4x, which is already given to us here as 1280. So this 1280 will get divided by 5 into 4 so as to give us x square. This x gets multiplied with this x. 5 into 4 is 20, zeros cancel. So x square here becomes 128 by 2, which is nothing but 64. So x square equals 64. X will equal to 8, because we know that 8 square is 64. So now as x is 8, 5x will become 5 into 8, which is 40. 4x will become 4 into 8, that is 32. Perimeter is twice of L plus B. So this is 2 times 40 plus 32, that is 2 times 72, that is 144 meters. This shall be the required answer, that is the perimeter of the plot. Now if the ratio between the length and perimeter of a rectangle is 8:30, then find the ratio between the length and breadth of the rectangle. So the ratio which is given to you is between the length and the perimeter. So length is as it is, and perimeter is what? Perimeter is 2 times L plus 2 times breadth. And this is 8 and this is 30. So let us mark this as 8x and 30x. Now length we already know is 8x. So can we substitute this value here? Now perimeter we know is 2L plus 2B, and perimeter here is given as 30x. So we will substitute this 8x in place of this L. So it shall become 2 into 8x plus 2 times B. Well, this is 16, goes to this side. So 30x minus 16x is equal to 2 times B. So B here is 30x minus 16x, which is 14x. And this 2 shall come in the denominator. It shall become 7x. Now this is one way. Another way is we already know that perimeter is twice of L plus B. So L plus B here is perimeter by 2. L you can directly take here as 8x plus B. And perimeter by 2 is 30x by 2, which is 15x. So B here is 15x minus 8x, that is 7x. Now the ratio between the length and the breadth of the rectangle, well, length is to breadth. Length we already know is 8x. Breadth we already know is 7x. So the ratio turns out to be 8 is to 7. This shall be the answer. If the radius of a circle is increased by 50%, then by what percent will the area of the circle increase? Now, what is the original area of a circle? This we know is pi r square. Now, radius we are increasing by 50%, which means the radius becomes 1.5 times itself. So, the new area shall become pi times 1.5 r. Now, this is the new radius. The new radius is 1.5 times itself because there is a 50% increase. So, this shall become square. So, it becomes 1.5 square is 2.25 and this times pi. So, this here is 1 plus 1.25 times pi, as we have learned in the percentages. Whatever comes after 1 in the decimal, that much is the increase. So, this is the increase. So, area of the new circle increases by 125%. So, as we have already learned in percentages, 1.5 times is 50% increase, whatever comes apart from 1. The amount of figure more than 1 is 0.5, which is 50%. So, similarly, 2 times is 100% increase. 2.25 times is 125% increase. 2.5 times is 150% increase. Now, similarly, 3.5 times shall be 250% increase. So, these are the basic fundamentals that we had learned in percentages as well. Just revising them in relation to, with the purpose to understand how did we get 125% increase from 2.25 times. A wire is bent into a circle of 42 centimeters diameter. Now, if the circle of wire is opened and a square is made with it, then what will be the side of the square? Now, here we have a circle whose diameter here is 42 centimeters. So, diameter is 42. Now, basically, we are talking about a wire here, right? So, you started, bend the wire from here and to here, and then you formed a circle out of it. So, that means you have created a boundary which looks like a circle. When you will open that circular wire, it will become a straight line. So, this boundary is called circumference. So, what we are bothered about here is to find out the circumference of the circle, which will become the length of the wire. So, here circumference of the circle shall be equal to length of the wire. Now, diameter is already given as 42 centimeters. So, radius here shall become 21 centimeters. And the circumference of the circle is given by 2 pi r, which is 2 into 22 by 7 into the value of r here is 21. So, the value of r here is 21, and for calculation purpose, please take pi equals to 22 by 7. In certain other cases, you can also take pi equals to 3.14. But here, because we have 7 in the denominator, which will easily cancel this 21, which goes by 3. So, this is 2 into 22, that is 44, into 3, which gives us 132 centimeters. Now, this is the length of the wire. And you're going to make a square out of it. Now, we know that a square has all the 4 sides equal. So, this will also be equal to the perimeter of the square that you will form from this wire. So, 4a equals 132. A, which is the side of the square, will be equal to 132 by 4. That will come out to be 33 centimeters. So, this is the side of the square, and this shall be our answer as well. A wheel has a diameter of 7 meters. So, this is a wheel, a large wheel of diameter 7 meters. So, let us say this is the diameter is 7 meters, which means radius here shall be 3.5 meters, which can also be written as 7 by 2 meters. For calculation purpose, we may require it. If the wheel completes 35 rounds in 1 minute, then in how much time will the wheel cover a distance of 6.93 kilometers? So, first of all, let us find out how much distance does the wheel cover in 1 minute. So, the distance covered by the wheel in 1 minute shall be the circumference of the wheel into number of rounds that were completed in 1 minute. Now let us find out the circumference of the wheel. Now this would be 2 pi r, which again can be written as 2 into 22 by 7 into 3.5 into 7 by 2. We are using this for the ease in calculation, into the number of rounds, that is 35. So quite simple, these 2 and 2 gets cancelled, the 7 and 7 gets cancelled, we are left with 22 into 35. 35 into 2 is 70, 7 remainder, 35 into 2 is again 70 plus 7. So 770 meters is the distance which is covered in every minute. So now time taken, cover 6.93 kilometers shall be 6930 meters. Well, 1 kilometer is equal to 1000 meters. So I have just simply multiplied 6.93 here with 1000 to convert kilometers into meters, divided by 770 meters per minute. So meters cancel, your answer has to be in minutes. And that's exactly what we are supposed to find out. So zeros cancel. So 77, if you multiply this with 9, 7 9s are 63, 6 remainder, 7 9s are 63, plus the 6 shall give us 693. So 77 into 9 shall make it 693. So this means the distance of 6.93 kilometers shall be covered in 9 minutes. That, my friend, answer here. If the radii of two circles in a ring are 16 centimeter and 12 centimeter, then what will be the area of the solid part of the ring? So let us say the radius of the inner circle here is small r in lowercase, and the radius of the larger circle is capital R or r in uppercase. And you're supposed to find out this area of the ring. So the area of the solid part would be nothing, but it would be area of large circle minus the area of the smaller circle. Now the area of large circle has the radius as 16 and smaller has radius as 12. And also we know that area of a circle is denoted by pi r square. So this shall become pi into 16 square minus pi 12 square. So pi we take here as common. So we take the value of pi here, so this shall become 16 square minus 12 square. Pi is also equivalent to 22 by 7, and 16 square is 256, 12 square is 144. Do the subtraction part here, 256 minus 144, we have done this before, it is 112. So 7 ones are 7, 11 minus 7 is 4, 42, 7 6 are 42. So 22 into 16 is what we get, 16 twos are 32, so 3 is remainder, 16 twos are 32. Plus 3 is 35. So 352 centimeter square shall be the area of the solid part. This is your answer. Now in a semicircular ground, there is a 180 meters long and 120 meters wide rectangular tank. This, let us say, is the semicircular ground. And there is a rectangular tank. 180 meters shall be its length and 120 its width. If the area of the remaining part of the ground is 40,000 meters square, then what is the radius of the semicircular ground? Now the area of the remaining part, this is the remaining part, apart from this tank, whatever remains, its area is 40,000 meters square. So you will have to find out the radius of the semicircular ground. Now first find out the area of the semicircular ground. Now the area of the ground, which is a semicircular ground, can be found out by adding up the area of the rectangular tank and area of the remaining region. Now the area of the rectangular tank we know is 180 into 120, that is length into breadth, and area of the remaining region we already know is 40,000 meters square. So this becomes, well, 18 into 12, 18 into 10 is 180 plus another 36, 18 into 2, so 216. 21600 plus 40,000 shall become 61600. Now this shall be the area of the ground in meters square. Now this ground is semicircular, and area of a semicircle or half circle, see, area of a circle is pi r square. You have it, it becomes pi r square by 2. So this means that pi r square by 2 is equal to 61,600. R square here becomes 61,600 into 2. This 2 goes here. And pi we are taking here as 22 by 7 goes to the other side, reverses, becomes 7 by 22. So 2's cancel here, becomes 11. 11 divides 61600 as 11 5s are 55. 6 remains 66, so 5600 to be multiplied with 7. Well, now here if you see 5600 can be rewritten as 7 into 800, can still be rewritten as 7 into 2 into 400. Using this calculation, we get r square here as 2 into 400 into 7 into this one, this 7. So 5600, I wrote it as 2 into 400, that is 800. 8 7s are 56. And this 7 I have taken down as it is. So r square equals this much, which means r here will be square root of 2 into 400 into 7 into 7. Now for 7 into 7, we'll get 1 7 outside. For 400, 400 is square of 20. We will get a 20 outside. So what remains inside is root 2. So the radius of the semicircular ground works out to be 140 root 2. And this here shall be our answer. The area of a trapezium shaped field is 480 meters square. The distance between the two parallel sides is 15 meters. And one of the parallel sides is 20 meters. So let us take a trapezium here. It could be of this shape. We can also take a regular trapezium of this shape. Either ways, this will become the height. So this is 15 meters, the distance between the two parallel sides. This is 15 meters, distance between the two parallel sides. You can take any of these figures. You don't have to draw both the figures. And one of the parallel sides here is given as 20 meters. So let us say this smaller side here is 20 meters. It could be larger also. And area is already given to us as 480 meters square. It is already specified. So now one of the parallel sides is given to us as 20 meters. Another parallel side, let it be B, and the height here is given to us as 15 meters. And area is given to us as 480 meters square. Area of a trapezium is half into height into sum of the two parallel sides. So area we already know is 480. Then half into height, which is 15. One of the sides is 20. The other is unknown, which we have assumed as B. So rest all is about solving. So this goes up on the left hand side, becomes 480 into 2 by 15 equals 20 plus B. So here 15 will divide this 480. 15 into 3 is 45, remainder 3 combines with 0 becomes 30. So 15 into 2, so 32 into 2 once again becomes 64. From 64 you subtract 20, get 44 meters as the length of the other side. This shall be our answer here. Now in a quadrilateral, the length of a diagonal is 10 centimeters, which divides the quadrilateral into two triangles. Now the heights of triangles with the diagonal as the base are 4 centimeter and 6 centimeter. Find the area of the quadrilateral. Now to avail some ease and comfort for calculation, let us simply assume that this a trapezium, because it says a quadrilateral, it could be an irregular quadrilateral also. Anything could be there. Only thing is that we are drawing a diagram here in rough. This is a diagonal whose length is already given as 10 centimeters. And it divides the quadrilateral into two triangles. Yes, this is one triangle, this is another one. One triangle may be bigger than the other one. Heights of the triangles with the diagonal as the base. Now this is the diagonal, it is taken as base. This shall be one height, this shall be another. This will be 4, this will be, let us say, 6. We are going by assumption. We have to find the area of the quadrilateral. So the area of the quadrilateral will be the sum of the areas of these two triangles. So diagonal given to us, height of one triangle and the other is already specified. So area of the triangle we know is half into the length of the diagonal and the sum of the two heights. So this shall be written as this is half, the length of the diagonal is 10, the sum of the two heights is 4 plus 6. Well, 2 and 10 they cancel, works out to be 5, and this is 4 plus 6, which works out to be 10. So hence area of the quadrilateral works out to be 50 square centimeters. This shall be our answer here. Well, that brings us to the end of this session. Now please do revise this and solve enough number of questions so that the formulas and the concepts and various difficulty patterns would register adequately into your mind. We will meet again in the next session to discuss another topic. Till then, our best wishes are there with you. Please work hard and stay safe. Thank you.